Bismillahirrahmanirrahim. Today we are going to solve Cambridge O-Level Physics Paper 4 Alternate to Practical. We have the subject code is 5054 and the variant of this paper is 42. For the session of May-June 2024, we have 1 hour for this paper to solve, and this paper is carrying 40 marks. So we're going to start our question paper and we need to solve all the question. Okay, question number 1 is from the topic of electronics. A student investigate the resistance of a diode when different current flow through it. The student set up the circuit as shown in the figure 1.1. Part 8 is this is a diode circuit. You can see the diode is present in the circuit diagram, and this circuit diagram is the forward bias. Okay, part A is that the student connects a voltmeter into the circuit to measure the potential difference across the diode. Measure the potential difference. This is a very important information. On figure 1.1, draw the symbol for the voltmeter connected to the measure the potential difference across the diode. So we need to connect voltmeter in parallel with the diode. So we just need to simply draw like that. This is the diode, and we're gonna show our voltmeter like that. So this would be our circuit diagram. So this question was carrying 1 mark. Hopefully to get the idea of it. Moving to its part B. Okay, the student uses a connecting leg to connect the terminals X and Y together. It closes the switch, record the voltmeter V, record the ammeter reading I, open the switch and removes the connecting lid. Shows the reading. Figure 1.2 show the reading on the voltmeter and the ammeter. Okay, first you need to calibrate those reading. This is 0 and this is 1. It means 0 and 1, there are 5 points, 1 2 3 4 and 5. Each point is carrying the value of 0.2, then 0.4, then 0.6, then this value would be 0.8, and this value is 1. And you can see that the needle is between 0.8 and this is the first point, and each point is of, there are 5 division between this. So you're gonna divide 0.2 to 5. So each reading value would be 0.4, or you can say it would be 0.04. So this would be like that. This is 0.8, this is 0.84. Again I am repeating this is 0.8, this is 0.84, and between this reading would be 0.82. Now similarly this reading we need to record, and from 0 to 1 this is easy, 0.1, 0.2, 0.3, 0.4. so the reading is between 0.3 and 0.4. This is 0.4, this is 0.3, this is the between reading, and between reading would be 0.35. Okay, so this was actually the A part, in which you calculate the resistance R using the equation R is equal to V. Record your answer in the top of the table. Okay, first you need to plot this value which I have here. Over here 0.82 and over here 0.35. The formula for R is V by I. So you're gonna divide V by I and you get the value that is equal to 2.3. So this is 2.3. The answer you're gonna write over here. Moving to its D part. The student connects a 3.3 ohm resistor between terminal X and Y. Closes the switch, record the voltmeter reading V in the table 1.1, record the ammeter reading I in the table 1.1, open the switch and remove the 3.3 ohm resistor. Repeat the procedure for the resistor 6.8 ohm and 10 ohm. Complete the table 1.1 by inserting the missing values. Okay, this is our table, and we know that the formula for the I would be R divided by formula for the I would be V divided by R. So value of V is 0.81 and the value of R is 3.7, and you're gonna divide and you get the answer 0.22. And for this you're gonna need to divide 0.81 and 0.19, you get the value of 4.3. So this is how we have completed the table and insert the missing values. Now moving to its E part. E part say that as the resistance between the terminal X and Y is changed, the current in the circuit changes. Examine the result in shown in the figure table 1.1. Describe how the change in the current affects. So you can see that the voltage across the diode. When the current decreases, there would be no change in the value current is decreasing, but there is a very little change, or you can say negligible change in the reading of voltmeter. Current is decreasing, but voltmeter reading is not changing. So you're gonna write as the current decreases, no change in the voltage, or a very little change you can write. Its second part is the resistance of the diode. You can see that resistance is increasing and the current is decreasing. So we can say that as the current decreases, the resistance increases. So current and resistance are inversely proportional to each other. Current is decreasing, resistance is increasing. So we're gonna write that as the current decreases, resistance increases. Moving to its second part, a student set up the circuit using the diagram in the figure 1.1. The student find that when connecting, the LED is connected across the terminal X and Y and the switch is closed, the emitter reading does not give a reading. It means that the connections are wrongly connected. The emitter is not broken, suggests the error that student has made while assembling the circuit. You need to write only one reason. I have written 4 reasons because examiner has provided all those 4 reasons. So either you can write power supply connected with reverse terminal, or you can write ammeter connected in the wrong way, voltmeter connected in series, and diode is connected in the reverse direction. When diode is connecting the reverse direction, it would be reverse bias, no current will flow, so it could happen. So you can write any one of the reasons from the given reasons to get the full marks of it. This is how we have completed question number 1. Moving to question number 2. Question number 2 is that a student investigate the rate of cooling of hot water in the test tube under different conditions. The student arranges a test tube as shown in the figure 2.1. Pours 200 centimeter cube of cold water into the beaker. Pours hot water into the test tube until it approximately 1/3 full. Lowers the test tube into the beaker of cold water until the level of the hot water in the test tube is below the level of the cold water in the beaker as shown, and places thermometer on the test tube. Pause for the approximately 30 seconds before measuring the temperature and starting a stopwatch. Okay, waits for oxygen, which I read as a box. It is written as waits for approximately 30 seconds. Okay, then apparatus is given. Now we need to move to other page. The student measure the temperature theta of the hot water in the test tube. The thermometer is showing the reading. Read the thermometer, record the temperature in the table 2.1 when time is equal to 0. So when time is equal to 0, it would be 71, 72, and this reading would be 73. So at 0 second the reading will be 73. You need to record this in the table. Okay, you need also complete this table by writing its unit seconds, Celsius and Celsius degrees over here. Moving to its B part. The student measure the temperature theta of the hot water every 30 seconds for a further 180 seconds. So every 30 seconds, so I have made this 30, 60, 90, 120, 150, 150 with the difference of 30 seconds. Okay. Complete the column headings by adding appropriate units. Complete the time column, okay, which I've already completed. Okay, describe in detail one precaution that student must take to measure to make sure the temperature measurements are as accurate as possible. So you need to write any one reason. I have written more than one reason. You can write I perpendicular to scale to avoid parallel error. This is the most important precaution that you need to be carefully identify. Or you can write keep stopwatch close to the thermometer. Or you can also write thermometer must be immersed or submerged into the water with 1/3 or 1/2 in the test tube. So you can write any one of the reasons from given three reasons. Okay, I have given three reasons. Moving to part D, the student repeats the procedure in A and B but with 200 centimeter cube of warm water instead of cold water in the beaker as shown. And the student reading with warm water as shown in the table 2.1. One of the student reading from warm water recorded into table 2.1 is anomalous. Anomalous means it does not follow the trend. So you need to identify the anomalous temperature reading and explain how you decided that this reading is anomalous. This is an easy question. You can easily identify by yourself by looking in the table 75, 68, 63, 58, 55. Then there is sudden decrease in so much temperature of 35. So this is anomaly. Then again the temperature is 52. So it must be that the student at 152nd has not recorded the reading accurately. So this is the anomaly, and you can anomalous reading is 35 degrees Celsius at 152nd. The reading does not follow the trend. You can write this reason, or you can write the reading is much lower than the previous reading. Okay, use temperature reading in table 2.1 to calculate the temperature decreases of the hot water in the test tube after cooling for 180 seconds in both the beaker of cold water and the beaker of warm water. Okay, for the beaker of the cold water, the difference is that you 73 to minus 34, this would be equal to 39, and for the hot water 75 minus 52, this is the difference would be 23. So we have calculated the temperature difference for both these two readings. Next part is how you have calculated. I'm repeating again, from subtracting highest minus the lowest reading for warm water as well for the cold water. So cold water 73 minus 34, 75 minus 52. Moving to its E part, use your answer to D part second, which we just have done. How the temperature of the water in the beaker affects the rate of the cooling hot water in the. So you need to calculate the rate of water. Rate of cooling is greater. Why I have written this? Because rate of cooling is in 180 second it's down to 39 degrees Celsius, and rate of hot water of cooling is down to 23 degrees Celsius. So it is simply that the rate of cooling is greater compared to rate of warm water. So for cold water you can calculate the rate as well, 73 minus 34 final initial minus final over 180, the time 39 by 8, that is 0.22. For warm water it would be 23 by 75 minus 52 over 180, it would be 23 by 180. 180 is the time, so 0.13. So the rate of 0.22 is far greater than compared to 0.13 the rate of warm water. Suggest one improvement of the experiment procedure to describe in A and B that allows a more valid comparison to be made between the two rates of the cooling. So you can write simply same amount of water or volume of water should be used using a measuring cylinder, or same initial temperature should be recorded at the start. You can see that the temperature at the start of this experiment is not the same, 73, and here is 75. So you can improve it by having the same temperature on both the sides. Okay, so this is the precaution. Moving to question number 3. Question number 3 is from the topic of movement. A student investigate the balancing of a meter rule which has a load of mass m fixed to it at the 0.5 at the 5 centimeter mark. The student places a pivot under the 50 centimeter mark of the rule. Okay, this is the 50 centimeter and this is the pivot mark. Places another load of mass m is equal to 50 gram on the rule. Adjust the position of the load with mass m is equal to 50 gram until the rule is as close to balance as possible as shown in the figure 3.1. So this is 0 to 100 centimeter and the rod is balanced at 50 centimeter. Figure 3.2 shows the position of the 50 gram mass when the rule is balanced. Okay. Okay, this picture is shown over here by zooming it, so you can calculate this 93.5 by writing by putting scale over here, and you can clearly see that this is 93 and this is 93.5, and similarly this is before 96, so the point should be 95.9. so this would be their starting point 93.5 and the ending point, that is equal to 95.9, and the difference between should be calculated. 95 minus 93, it would be 2.4, and the center of 2.4 should be dividing by 2, it would be 1.2. so the first part is take the reading from the rule and use that to determine the position of the center of 50 gram mass on the rule. So this was the 50 gram mass. So you have identified clearly by observing this. So the difference center of mass, it should be over here. The difference over here was 2.4 and 2.4 divided by 1.2. So it would be 1.2, but its starting point is 93.5. The starting point is 93.5, so you have to add 1.2 in it. So 93.5, because 1.2 the center of mass exists. So 93.5 plus 1.2, it would give you answer 94.7. So this question is mostly done wrong by the student because of its confusion related to this measurements. Okay. Calculate the distance of the D of the center of the 50 gram mass of the to the 50 centimeter mark. Record your answer on the answer line in the table 3.1 on the page 12. Okay. So this is simply, you can write that 94.7 minus 50, because at 50 there is a pivot. So taking the difference, how you get the 94.7 in the previous part, so the difference would be 44.7 centimeter. So this is the moment arm. You need to write this value in the table as well, over 44.7. Okay. This third part is calculate the value of 1000 over D. Record your answer on the answer line and table 3.1 on the page 12. 1000 over 44.7 would give you the answer, because D was we calculated in the previous part, it is 44.7. so 1000 over 44.7 is 22.37, or you can round it off or into the 3 significant figure, it would be 22.4 centimeter per centimeter. It is part B is, it is difficult to balance the rule exactly. Describe a technique that student uses to make sure that the value of D is as accurate as possible. So first you need to adjust the mass slowly until rule tilts one way, then adjust again until it tilts other way. So after so many adjustment, you can finally balance up to the center of mass. Okay, next part is the student repeats the procedure in A for the value of mass 60 gram to 100 gram. Okay, all readings in the table is given. We have already calculated, so you can calculate this by 1000 over 44 points, which we have also calculated in the previous part. Okay, that is equal to 22.4. On the grid provided in the figure 3.3 on page 13, plot a graph of M on the y-axis. So mass should be taken at the y-axis, and at the x-axis this value should be given 1000 over D. The axis do not need to start from the origin 0 0. This is a very crucial information. Draw the straight line. Draw the straight line of best fit. Okay, it means that all points must not be crossed. Okay, so we have given the scale of 15, 20, 25, 30, 35. This is x-axis over here. So we have started with 15 and we go up to 55. Okay. And for y-axis, we the table is starting from 50 and is going to 100. We have started from 45 and moved to 105. So at every point, you need to identify the graph. So first, we need to plot at 50. When the mass is 50, the value is 22.5. So it would be this value. Okay. When the mass is 60, the value is this, that is 26.5. And when the mass is 70, the value is this, that is 31. And when the mass is 18, the value should be 35.5. And when the mass is 90, the value of 39. And when the x-axis is 45, the value would be 100. So we have plotted all those points according to given coordinates. And now you need to draw the best fit line, and we have drawn the best fit line from our square. Hopefully you get the idea of this picture and how this graph has been plotted. This is a simple plotation. This is not a curved graph. This is a straight line graph. Okay, its other part is D part. Calculate the gradient G of line. Show all your working and indicate on the graph of the values. So we need to identify the points. We take the value gradient. The formula is y2 minus y1 over x2 minus. So we have taken 2 points, 28 and 65 and 38 and 85. This is here. 28 and 65 and 38 and 85. So we have taken our values, and after putting those values, our answer, the value is 85, y2 minus y1, x2 minus x1. The answer is 20/10 and the value is 2. Any answer between 2 to 2.4 would be considered correct. So examiner has clearly mentioned, if you had done this paper, your values come 2.3, 2.4, 2.1, 2.2. You don't need to confuse. All those values that are between 2 and 2.4 are considered correct, including 2 and 2.4 as well. Next part, the mass of the load fixed to the tool can be determined using the equation m is equal to 22.2 into g. We have just calculated the g. Put this value, you will get the value of m, that is equal to 44.4. This is an easy question. Suggest why this method of determining the mass m and fixed load is unsuitable if a movable load of mass 40 gram is used. It would not be possible to balance because it is a movable. When the mass is movable, we cannot fix the value of d. It increases and it sometimes go beyond the available length of the rod. So this you could write in your answer. So this was the question number 3 that have completed, and this question was carrying 14 marks, and this was the lengthy question with the graph. Moving to last question of our paper, question number 4. That is a planning of this question you should do. A student has a converging convex lens and needs to determine its focal length. Focal length, okay. Plan an experiment that will enable the student to measure the accurate value for the focal length of the lens. The focal length of a lens can be calculated using the equation f is equal to uv and u plus v, where u is the distance between an object and the lens, and v is the distance between the focus image and the object. Okay, examiner has clearly mentioned its variable. Figure 4.1 show some of the operators available. Triangular object hole cut into a place of a card. This is a card and triangle hole is cut, and this is the lens and this is the bench. Over here the image is formed. The lamp is connected to a power supply and can be switched on and off as required. Write a plan for the experiment, and your plan should carry list of any additional operators needed. Draw a diagram of the arrangement of the operators labeling U and B. So we have labeled this U and we have labeled this B. Okay. Explain briefly how to do experiments. State the steps taken to obtain a sharp focus image. Explain how to use this reading to determine the F. Okay. So I have written this already. Use the meter rule. First we need to use the meter rule to measure the value of U and B. After measuring the value, the image of the bulb will be formed on a piece of cardboard placed at a distance V from the lens. We can see from the diagram. Then move the lens and the screen to obtain a sharp image. When the image is sharp, it means that it is at the focus. So the length would be focal length. A sharp image on the cardboard, and the note where the values of U and V. Conduct the experiment in the dark room. Repeat the experiment. Record 6 sets of reading for U. Find the average. Find the average and calculate the value of F. And you can also draw the label diagram by between U and B and make a graph like that. And you need to put those value of U and V into this, and after that you get the answer for the focal length. So this was complete paper that I have just solved. If you do have queries related to this paper, you can ask in the comment section. It will be answered in detail. Do share with your friends who are giving this physics paper in O level, and don't forget to subscribe my channel for for future videos as well. Hopefully you get the understanding of paper. Thank you so much for watching this paper. Allah Hafiz.